We are starting with the lecture of composite shapes, the 5th class and the final class. Now, the first question, it says, when a solid rectangular wooden block of oak floats 60% of its height is underwater, the first part, what fraction of its height is above water? So now the rule is, if 60% is underwater, therefore 40% of its height is above water. So that's a simple subtraction. So therefore, what is the fraction? 40 over 100. That comes out to be 4 over 10. That comes out to be 2 over 5. That is the answer for the first part. Now let's move ahead and read the other parts. The other part says that a block of oak has a length of 60 centimeter, width 50 centimeter, height h centimeter. It floats with 15 centimeter of its height underwater. Find the value of h. Now the total height is h, 60% is underwater. This value is 15. So now what we will do is that 60% of h equals to 15. Therefore, h equals to 15 into 100 divided by 60. Therefore, 15 ones are, 15 fours are, and then this 100 divided by this 4, h comes out to be 25 centimeter. That's the value of h. So the first part is done. Now it says in the diagram, it's the same diagram that's shown above. In the diagram, the shaded region represents part of the surface area of the block that is in contact with water. Now, this is something important. So we are interested in the shaded region represents part of the surface area that is in contact with water. So now we can see this front is in contact with water. The same goes at the back. This region would be in contact with water. This region is in contact with water. That goes on the other side also, and then the base. So there are 5 faces that are in contact with water. The first face, that is this one. This is h and 50. So that is like this over here. Let me write this. So this is h into 50. That's 25 into 50 multiplying by 2. There are 2 faces. Then there is this green shaded region that is in contact with water. So this one is 15 times 60. This is 15 times 60. Again, there are 2 faces. And then there is the base area. That is 50 into 60. 50 into 60. There is only one surface because it's only the bottom. So this total surface area is the sum of all these. This plus this plus this. So let's multiply 2 into 25. That's 50. 50 into 50. That is 2500. And 2 into 15 is 30. 30 into 60, that is 1800. And 50 into 60, that is 3000. And we add it all up using a calculator, we get this answer. Now, let's look at part B. Part B says, a solid cylinder made from a different type of wood floats in water. The shaded region represents part of the surface of the cylinder that is in contact with water. So this is the part that is in contact with water. The right-hand diagram shows the circular cross-section at one end. So this is the circular cross-section. That is this thing over here. So this is the line AB. This is the line AB over here. And let me highlight some other important points, such as this is AB that goes like this. This is AB that goes like this. And then this blue one is this AB, this blue one is this AB. And what else is there? Now it says that the center of the circle is O, that's right over here. Water level reaches the point A and B on the circumference. Reflex angle is 220, that's over here. The cylinder has a radius 9 and length 35. This 35 is right over here. So let me highlight this. This 35 centimeter, that is right over here. And this radius is the red one, that is 9 centimeter. Now it says calculate the area of the curved surface of the cylinder that is in contact with water for 2 marks. That means if I know this arc length, that's a major arc length. And if I multiply it with this 35, that is the surface area, the curved surface area that is in contact with water. Now, first of all, let me calculate the arc length. So major arc AB, that is 220 over 360 into 2 into pi into r is 9. Now let me grab my calculator and let me multiply it out. So 22 into 2 into 9. I'm just multiplying the numerator, that is 396. And there is a 36 below. I've cancelled off the zeros. I've taken 22, I have 2, I have 9, and 36 is there, and this is pi. So 390 over 36, that's 11. So this answer comes out to be 11 pi centimeters. That's the major arc length. And the area of the curved surface, so curved surface area that is in contact with water, that is 11 pi multiplying with 35. So 11 into 35, that's 385 pi. So I'm leaving the answer in terms of pi for right now, and naturally I can multiply it with 3.142 and I'll get my answer. And then it says the surface area of one end of the cylinder that is in contact with water. So one end of the cylinder, that is this one. That is the area of this sector plus the area of this triangle. So now let me work this out. So I think I'll be needing more space, and I think I've broken this up into parts. So if I can get hold of this thing, which will be kind of difficult, because this will then be cancelled out. Okay, let me see if I can fit it over here. No, it won't. So I'll just skip this. Now let me work this out. So now this thing is like this. That's the triangle. And then there is the blue line. And what else is there? Now this thing is there. That is the curved surface area. Something like this. Okay, let me just make it using this. It goes like this, and then this thing. Okay, so now this goes like this, and I need to label the radii. Okay, so now I'm focusing on this thing. That is this part over here. The surface area of one end of the cylinder. Now 220 is subtracted from 360. This is 140 degrees. This is 9 centimeter. This is 9 centimeter. So area of this triangle is half A B sine of 140 degrees. I'll use a calculator. Let me first finalize the working. Then over here, this is 220 degrees. This is 9 centimeter. So therefore, area of the sector, the major sector, this is 220 over 360 degrees. And this is multiplied with pi into r square, that is 9 square. So now 22 into 81 divided by 36, that's 49.5 pi. So this is 49.5 pi. Let me write this thing as 49.5 into 3.142. Into 3.142, this comes out to be 155.529, 155.529 centimeters square. And this is coming out to be sine of 140. So let me calculate 140. Let me calculate sine, multiplying it with 81, multiplying it with 0.5. This comes out to be 26.03. This is 26.03 centimeters square. Therefore, total surface area is the addition of this and this. So 26.03 plus 155.529. Let me write this thing as 53. That comes out to be 181.56. And centimeters square, that is 182 centimeters square. So now let me check this thing. This is part B, part 2. Part B, part 2, 181 to 182. This is 182 that we have gotten. So this is the answer. This we have left in terms of pi, and this 25 is perfect. This 2/5 is perfect. This we did not add it up, but that is this thing. So let me just show you this thing. That is this one, 385 into 3.142, 385 into 3.142. This comes out to be 1209.67. 1209, basically it will come out to be 1210 centimeters square. That is this part. So this is 1210 centimeters square. We have also gotten this. And before that, there is this part, which is addition of these things. That is 2500 plus 1800 plus 3000. This comes out to be, if I'm not mistaken, this is 2 into 25 into 50. 50 into 50, that's 2500. 15 into 60. 15 into 60 into 2, that is 1800. So this is good, this is good. And 50 into 60, that is 3000. That's also good. So therefore, this comes out to be 7300. So now this is 7300. I don't know why it is written as 63. 50 into 15 and 60 into 15. I think maybe I've taken a value wrong. So this is 50 into 15. Okay, this is not H, this is 50. So let me just correct this. So this is 15, this is 1500, and that makes the answer correct. This is 1500 in black. And this comes out to be 6300 centimeters square. So this thing also is corrected. Now let me move on the last part, which says the distance between the water level AB and the top of the cylinder. The distance between water level AB and the top of the cylinder. We are interested in this distance. Let's call this distance as D. Now we know that OA, this is radius, OB, that's radius, and this thing also will be the radius. That means if I'm able to calculate this much, this small one, and focusing on this right angle triangle, so let me label this thing. I'm just changing the values. So let me first focus on this. Hold for a second. So therefore, this is the purple one that goes like this. This is the green one that goes like this. Actually, this is the red one. This is the green one that goes like this. Now let me just draw this diagram. This green is like this. This purple goes this way. This red goes this way. And this is, this is 220. This is 140. Therefore, just this much is 70. So just this much is 70 degrees. This is 90. This is 9 centimeters. Can I calculate this small height? Let me call this thing as M. So therefore, from here till here is M. So cosine of 70 degrees is M over 9. Therefore, M is 9 cosine 70 degrees. So what is cosine of 70? That is 0.342 into 9. That comes out to be 3.078. This is 3.078. But now if I draw a line from here all the way till the end. So now I'm going this way, this way, this way, all the way here. Let me label this thing as C. And let me label this thing as M. So therefore, this is O, this is M. OM plus MC. OM plus MC is OC. OC is the radius. This is 9 centimeter. And M is technically OM. That is 3.078. So therefore, MC is 9 minus 3.078. Let me do the subtraction. 9 minus 3.078. This comes out to be 5.92. 5.92 centimeter, correct to 3 significant figures. This is the distance between the water level AB and the top of the cylinder. Water level AB and top of the cylinder. This is the distance that we have calculated. And there it is. This is the answer that we got. So this is all good. So that's how this question is completed. Now, if there is any question, please ask, or if there is none, just acknowledge it on the WhatsApp group. Now, let's look at this question. The question says, a fuel tank is a cylinder of diameter 1.8 meters. So let me do some highlighting. Fuel tank is a cylinder, the diameter is 1.8. So right away, let me write that the radius is 0.9 meter, or I can write this thing as 90 centimeters. The first part, it says the tank holds 25,000 liters when full. Given that 1 meter cube is 1,000 liters. So we have 1 meter cube is 1,000 liters. And calculate the length of the cylinder, give your answer in meters. Now, volume of the cylinder. So A part 1, volume of the cylinder, that is pi r square h. So the volume is 25,000 liters. So that is 25,000 liters will become M, what you call, no, let me not use M. Let me use V. So therefore, V into 1,000 is 25,000 into 1. So V comes out to be 25 meter cube. That is the volume in the cylinder. So the volume is 25. Pi as it is. R is 0.9. We are working in meters. And into H, so H will automatically come out in meters. So H comes out to be 25 divided by 0.9 into 3.142. Again, we need to use the calculator. 3.142 into 0.9. That is this thing. And let me reciprocate this and then multiply with 25. This comes out to be 8.84079. Let me write this thing as 8.84 meters. That is the final answer, correct to 3 significant figures. That's the first part. Now here comes the second part. Now the question says, the diagram shows the cross section of the cylinder. So this is the cross section. Center O containing some fuel. CD is horizontal and is the level of the fuel in the cylinder. So this blue line CD, that's the level of fuel in the cylinder. AB is a vertical diameter and intersects CD at E. So now this intersects, given that E is the midpoint of OB. So E is the midpoint of OB, and what I see is that the radius of the cylinder OD is also there. So if this is OD, OC is also 0.9. And E is the midpoint. Therefore, if E is the midpoint, therefore CE and ED is the same. And it's an isosceles triangle. So therefore, this angle right over here, it's a 90-degree angle. Okay, that is so far so good. First of all, it says, given that E is the midpoint of OB, E is the midpoint of OB. Now, how much is OB? First of all, OC, OB, and OD, they all are equal to radius. They all are equal to 0.9. Let me write down the units. That is meters. And E is the midpoint. So therefore, OE is half of OB. There is OB. That comes out to be 0.45 meters. Okay. So therefore, show that EOD. So now let me draw a line over here, a red line over here that goes like this. So this is the red line. This is the blue line that goes like this. And it's not drawn to scale. That's always understood, but again, re-emphasized. So now this is O, this is E, this is 90, this is 0.9, this is D, and OE is 0.45. This is 0.90. So the angle EOD, let me label this angle as theta. Let me label this angle as theta. Therefore, cosine of theta is 0.45 divided by 0.90. Cosine of theta is 0.5. Theta is cosine inverse of 0.5. Now, this is such a famous value that we know that the answer is 60 degrees. Now, just for fun, let me give you two values that you will come across a lot in trigonometry. That is sine of 30 degrees and cosine of 60 degrees. They will be the same. They will be 0.5. Similarly, let me just erase this. Let me use another color. The other one is tangent of 45 degrees will come out to be 1. These are two famous values that you will come across. So therefore, since these values were handy for me, so that therefore I calculated it without the calculator. So the first part is done. Show that this thing is this much. Calculate the area of the segment BCD. Now we are interested in finding this area. What we can do is that we can find the area of the complete sector, subtract from it the area of the triangle, and we will get this area. So now let me focus on this part. That is part B. Area of sector. Always make sure to write the name of the sector. That is OCBD. This angle is also 60, so the total angle will be 120, and the radius is 0.9. So therefore, this is 120 divided by 360 into pi into r square, which is 0.9 square. This is 1/3, this is pi, and 0.9 into 0.9, that is 0.81. So 0.81 divided by 2 is 0.405 pi. This is 0.405 pi. Pi has a value of 3.142. Multiply it with 3.142. That comes out to be 1.27251 centimeter square. That's the area of the sector OACBD. OACBD. This is step number 1. Now, step 2. That is area of triangle. What's the name of the triangle? That is OCED. So this is OCED. That's half AB sine C. Half into 0.9 into 0.9 into sine of 120 degrees. So this is half. This is 0.81. Sine of 120 degrees, that is 0.8660. So let's multiply 0.8660 into 0.5 into 0.9 into 0.9. This comes out to be 0.35073. And here comes step number 3. That is the difference between area of sector and area of triangle. That is what we are looking for. 1.27251 minus 0.35073 minus 1.27251. This comes out to be 0.92178, which is 0.922 meter square. That is the answer for this part. Calculate the number of liters of fuel in the cylinder. What is this? The number of liters of fuel in the cylinder. So now I'm working on part C. So that is the volume that we are looking for. So volume is cross-sectional area multiplying with length. What is the cross-sectional area? Isn't that the area of the segment? And what is the length of the cylinder? The length of the cylinder is over here. Calculate the length of the cylinder. That is this thing. We'll use the unrounded value, 8.84079. So length is 8.84079. Cross-sectional area, let's also use the unrounded value, 0.92178. 0.92178. So let's multiply these two. So multiplying it with 8.84079, that comes out to be 8.149. This is meter cube. Now we know the conversion, that is 1 meter cube is 1000 liters. So this is 8.149 meter cube. So therefore 8.149 into 1000. So this comes out to be 8149 liters rounded off. That is 815 liters rounded off to 3 significant figures. This is also 3SF. And this is more than 3SF, more than 3SF. Final answer is 3SF. The same goes over here. This is 3F, SF. This is the unrounded value. So now let's double check the working. There is part B left. Let me first double check this. This is 9.82.4974880. Let me double check. Okay. Fuel tank is a cylinder of diameter 1.8, radius is 0.9, 25,000 liters, that is 25, that is correct. This is pi r square h. Okay, I made a small mistake. That is, I forgot to put the square over here. Put the square over here. So let me just use this value, because based upon that, I'll be getting the last value also correct. So let me just highlight this. So this is 0.9 into 0.9 into 3.142. And let me just reciprocate and multiply it with 25. That is 9.823. That is 9.82, correct, to 3SF. That's the answer for this part. So this one is 9.82. That is perfect. This was done. This is 0.497 or 0.498. Okay. Calculate the area of the segment BCD. That is 60. This is 60 over here. This is 60. That's 120. And the radius is 0.9. 120 over 360 into pi r square. This is this. This is this area of the triangle. That's half AB sine C. So this is half into 0.9 into 0.9 into sine of 120. Let me just double check this value. So 120 for a second. And I'm using the sine, that's 0.8660. That's also got into 0.5 into 0.81. That is 0.35. That's also got step 3 is the difference between the two. BCD, BC, and D. Yeah, that's the whole thing. I don't know why this answer is coming out to be different. And over here, let me use this value, which is this one. So let me just do the correction. Okay. So first of all, the length value was 9.823. So this is 9.823. So let's multiply it out. 9.823 into 0.92178. This is 9.054. Now, was this answer correct? 9.054. No, this is not correct. Something is missing from here. I think maybe I made some silly mistake. 120 over 360, that is 1/3. This is all good. And this is pi into 0.81. So 0.81 divided by 3. Here's the mistake. This mistake is this thing. I think I divided by 2. So let me just correct this thing also. So this is 0.27. This is 0.27 into this thing. So 0.27 into 3.142, this comes out to be 0.84834. And this is, I have to change this. This is changed. This will be changed over here. So a lot of arithmetic mistakes over here. This is 0.84834 minus 0.35073. This is 0.49761. 0.49761. This is 0.498. This is 3 significant figure. This we will use for the next part. 49761. 0.49761. Now I can multiply comfortably. 9.823. This is 4.888 meter cube. That's this is 4.888 into 1000. That's 4888 liters. And this is the 4th significant figure. So let me write this thing as 489 liters, correct to 3 SF. That's 4890, correct to 3 SF. 4890. Don't forget the 0. So as you have observed that since a lot of multiplication is involved, you need to be very careful. There were 2 mistakes that I did. I don't know, for some reason, I was thinking about half. So I divided by 2 instead of 3. Then I got it corrected. And over here, I made another mistake, that was forgetting to square it. So it's a blessing in disguise that you're seeing these mistakes before your exams. Now let's focus on this part. That is this part. Volume of sphere is 4/3 pi r cube. But remember, this is a hemisphere over here. A different fuel tank. So it's not the same one. It's a different fuel tank. Consists of a cylinder of diameter 1.5 and a hemisphere of diameter 1.5 at one end. So it's a composite shape. The volume of the cylinder is 10 times the volume of the hemisphere. Calculate the length of the cylinder. Now, what is this question about? It's about that. Let me write, first of all, if I write for the cylinder, volume of cylinder, this is pi r square h. This is pi, this is 1.5 square, and h is what I'm looking for, the length of the cylinder. Volume of the hemisphere is half that of a cylinder, half that of a sphere. That is 2/3. The half and 4/3 simplifies. That's 2/3 pi r cube. That is 2/3 pi, and this is 1.5 cube. Can I write this thing as 2/3 pi into 1.5 square into 1.5? Yes, I can. Now it says volume of cylinder. Volume of cylinder is 10 times volume of hemisphere. So this is 2/3 pi into 1.5 square into 1.5. That is this thing. And volume of cylinder is this thing. That is pi into 1.5 square into h. And the ratio is 10 times. So this is 10 over here, and then there is equal over here. Now let's multiply it out. So therefore, the pi's and the pi's cancels out. 1.5 square and 1.5 square over here cancel out. No need to use the calculator till this moment. And then we have 10, we have 2, we have 3, we have 1.5. So let's take 10 into 1.5, which is 15. 15 into 2 divided by 3. That's 30 over 3. That is 10. So h is 10. This is an exact value. there is no rounding off. So it's not always necessary to use the calculator. Just look at this working. Because I realized it because it was for 2 marks, and I have a habit of just putting in the value when it's most needed. But since I was thinking, the examiner was thinking about the ratio, therefore I reserved my pi till last. I even broke this 1.5 cube as 1.5 square into 1.5 so that the cancellation is easier. And that is how you get this answer. So there it is, H is 5. I think it is 10. 15 into 2 is 30. And this is a square. Hold for a second. This is a tick mark, my bad. So let me just double check. That is 10 into 2 into 1.5. So 10 into 1.5 is 15. 15 into 2 is 30. 30 divided by 3 is this much. The volume of cylinder is 10 times the volume of hemisphere. Hemisphere is 4/3. So this is half of volume of hemisphere, 2/3 pi r cubed. That's 2/3 pi into this thing. That's 2/3 pi into 1.5 square into 1.5. The pi's cancels out. And the 10 factor is there. The 1.5 square cancel out. H is left on the left. There is nothing left. And this is 1.5 over here. So 10 into 1.5 is 15. 15 into 2 is 30. 30 divided by 3. H comes out to be 10. So these are some of the questions that I have done so far. Now let's look at this question. The question has given us the surface area of a sphere formula, volume of cone formula, area of the curved surface of a cone formula. So that's the cone. And we can calculate the area of the curved surface. And we can calculate the volume of the cone. If they were to ask about the base area, the top of the cone, if it exists, that's a simple square. What about the surface area of a sphere? That's 4 pi r squared, but this is a hemisphere. And if it's solid, yes, it will have a circular base area. These are the dimension. This radius is 4, height is 16, radius is 3. Now the question starts. A drinking glass consists of a hollow cone attached to a solid hemispherical base as shown in the diagram. So the top is missing, only the curved surface area is there. And this is a solid hemispherical base. That means a curved surface area is there as well as a base area. And then all the dimensions are given. Calculate the total surface area of the solid hemispherical base. Calculate the curved surface area outside of the cone. Now let me focus on this part. So let me start the highlighting. Hemisphere has a radius 3, and the radius of the top of the cone is 4, and the height of the cone is this thing. So now we are interested in the cone that is shaded in blue, that goes like this. And we are interested in the hemisphere that's over here like this. And it also has this curved thing. So that's the curved surface area that goes like this. Now calculate the total surface area of the solid hemispherical base. Now, first of all, part A, that is about the hemisphere. So total surface area of a hemisphere, that's the curved surface area of a hemisphere plus the base area of a hemisphere. Curved surface area is half of 4 pi r square, and this is pi r square. Work in the formula mode. This is 2 pi r square plus pi r square, which is 3 pi r square. Now plug in the value of r is 3. That is 3 into pi into 3 square. That is 9 into 3. That's 27 pi. And we can write this thing in decimals, 27 into 3.142. So I'm grabbing my calculator. That is 27 into 3.142. This comes out to be 84.834. This is 84.834. And this is 84.8, correct to 3 significant figures. This is centimeter square. This is centimeter square. What about the next part? The next part is about the curved surface area of the outside of the cone. So now part B, curved surface area of the outside of the cone, that is pi r L. Now L is missing. So what I need to do is to draw a line from here all the way here. And this thing is 4 over here. So now this thing is 16. First of all, this is 16 over here. And the slant height, that is the orange one. That is actually the blue one. So the slant height is L. So this is 90 degree over here. This is 4. This is 16. This is L. So use Pythagoras theorem. L square is 4 square plus 16 square. That is, I'll put the square root later. This is 16. This is 256. Alhamdulillah. This is 256 plus 16. That is 272. So L square is 272. Therefore, L is square root of 272. That is 272. And let me calculate the square root. So therefore, 16.49, 16.492 centimeters. That's the value of L. I can even write this thing as 16.5 centimeter. This is 3SF. And this is not a square. This is just a length. Now over here, I should use the unrounded value. That is 3.142. Radius is 4. Slant height is L. That is 16.492. So 3.142 into, 3.142 into 4 into 16.492. This comes out to be 207.27. Let me write this thing as 207 centimeters square, correct to 3 significant figures. So now let me highlight the parts that we have done. So this is the answer for this part. And the answer for the top part is this thing. The two parts are done. So let me first check the result. 84.8 and 207. So this is 84.8, the red one. We got this. And 207, that is the next answer. So both these answers are correct. Let's move on. Now we are over here. The question is asking for the cone contains liquid to a depth of d centimeters. Giving you a reason, show that the radius of the surface of the liquid is 1/4 d centimeters. Why is this so? We have to understand. Now, I mean, that's how we have to start thinking. This 4 is the radius. This 16 is the height. So the ratio of the radius is to height is 4:16, which is 1:4. This is C, and this is part 1. Therefore, if I make R the subject, that's 1/4 of height. So instead of height, if I use D, so let me write over here that, let me write a D over here. Let me write a D over here. So if I compare R over D is 1/4, therefore R is 1/4 D. That is what we have proven. Because when the water level will fall down, it will still be in the shape of a cone. So the ratio of radius to height will remain throughout. That is the logic. What about the next part? The next part says C part 2. So this is C, and then part 2. It says the cone is completely filled with liquid. Calculate the volume of the liquid. So volume of the cone is 1/3 that of a cylinder. That is 1/3 into base area, which is the area of a circle, into height. I can use this formula. So this is 1/3 into pi into 4 square into h, which is 16. So this is 1/3, this is pi, this is 16, this is 16. That is 256 pi over 3 centimeters square. And let me use the value. that's 256 divided by 3 into 3.142. This comes out to be 268.117 centimeters square, which is 268 centimeters square, correct to 3 significant figures. So the C part 2 is done. Now, the last part, that is this. It says half of the volume of the liquid from the full cone is now poured out. Half of the volume of the liquid is now poured out. Using your answers to part 1 and part 2. So what is part 1? The radius and the diameter ratio. And part 2, that's the volume. Find the depth of liquid that remains in the cone. Okay, so now hold for a second. They are looking for the depth. Okay, so let me just highlight this. First of all, this green was part 1. So part 1, the answer is this thing. So let me highlight this, that radius is 1/4 of diameter. And part 2 is the volume of the liquid. So volume of the liquid is this much unrounded off value. That's the volume of the cone. So now, what do we need to do? So basically, it's a combination of these two. So this is C, part 3. First of all, volume remaining is half the volume of the initial one. That's half of 268.117. So therefore, multiplying it with 0.5, this is 134.058. Now, volume is 1/3, and then pi, and then r square, and then h. That is 134.058. But we know that the relation between radius and depth is the height, that is 1/4. Radius is 1/4 of diameter. So, and we are looking for the depth. So 1/3 remains as it is, pi remains as it is. And instead of radius, can I write 1/4 of height or depth, the whole thing square, into h, that is 134.058. So this is the tricky part. I can work in only one dimension. So h remains h, and radius is 1/4 of h, 1/4 of d, whatever symbol that you want to use. You want to use d, you can use d. So now let me write 1/3 into pi into 1/16 h square into h is 134.058. Now 3 into 16, that's 48. Pi over 48 h cube is 134.058. Now let me draw a thin line over here so I can work out over here. So therefore, h cube is 134.058 into 48 divided by 3.142. This will be h cube. Multiplying it with 48, divide by 3.142. This comes out to be h cube is 2048. Therefore, h is cube root of 2048. So grabbing the calculator, pressing the cube root button, that h is coming out to be 12.699. Therefore, h is 12.7 centimeters, correct to 3 significant figures. So there it is. The value of h is 12.7. That is done. And that is how we get this answer. And this thing was already done. So this is green and then purple. So this is green over here. R over D is 4:16. That's done. And this purple one is, we wrote 268 centimeter. So we wrote 268, just this much. So that's how this particular question is done. And that finishes the concept of mensuration.